Hello, good evening. Welcome to my channel. This is Obro, and we are going to start a new topic on turbo machines. So, what do you mean by turbo machines? Turbo machines means it's the story of turbine. We know the turbine we use in the hydroelectric power plant, even in the thermal power plant. So, the turbine is being coupled with the electrical generator to produce electricity, even in the thermal power plant, even in the hydroelectric power plants. So we know that there are the two types of turbine used in the two or three types of turbine used in the hydroelectric power plant. That is, one is the Pelton turbine and other is the Kaplan turbine. Pelton is being used in the high heads and high head water power plant, the hydroelectric power plant, and the Kaplan turbine is being used in the low heads hydroelectric power plant. So, what is the basic how the turbine works? Turbine is connected mechanically coupled with the electrical generator, and the thermal power plant, the boiler, supercritical boiler, they produce steam, and the steam is fed to the blade of the turbine, which makes the turbine to rotate, and ultimately it will be coupled with the electrical generator to revolve the generator to produce electricity for the power distribution purpose. And even in the same concept is being used in the hydroelectric power plant, where the water flows from the head of an hydroelectric power plant to the dams, which is fed to the blade of the turbine, which makes the turbines to rotate, and is coupled with an mechanically coupled with an electrical generator to produce electricity for a transmission distribution purpose. So here we will go to one by one part of the numericals for the turbine here. So this is one of the numerical for the turbine. That is an outlet flow reaction turbine has internal and external diameter of 2.4 meter and 3.0 meter respectively. So here first of all we have to understand what is the outlet this diameter of the turbine and inlet diameter of the turbine. So outlet internal diameter is given 2.4 meter and external diameter is given 3.0 meter. So the turbine has a radial discharge of 6 meter cube per second and is running at 200 rpm speed. So rpm, this is speed it is being used in the electrical machines, whereas in the dynamics of machines as well as machine design and various things, speed is mentioned everywhere, where we generally mention the formula that is pi dn by 60, that is the velocity of the blade or the blade of a turbine or a machine. So this is a 200 rpm and the total head of the turbine is 40 meter, and the wide of the wheel at the inlet and the outlet is 30 centimeters. So 30 centimeter, that is for the wide inlet and outlet. So now we have to neglect the thickness of the vanes. So we have to find the velocity of flow at inlet, velocity of the flow at outlet, and velocity of wheel at inlet. So here we have to first of all take the data. So what are the data being given in the numericals? That is the internal diameter 2.4 meter, external diameter is 3 meter, head of the turbine is 40 meter, discharge we take as Q is 6 meter cube per second, and speed is 200 rpm, and rate of the inlet B1 is equal to B2, both are same, inlet and outlet is 30 centimeter. We are making converting to meter, so we are dividing by 100, 0.3 meter. So first of all we have to calculate the velocity of flow at inlet. So velocity, that is the common formula, Q is equal to pi into d into b into vm. So here pi we are taking as 3.14, pi we will take as 3.14, and here we will just put the value of 3.14 instead of 22 by 7. D is the diameter of the inlet, that is 2.4 meter. We will put here 2.4 into b1. So what is b1? B1 is 0.3. That is the wide of the wheel at inlet and outlet. So inlet is b1, outlet is b2. Both are taken as 0.3 into vm1. So if we just multiply both here, we will get vm1 is equal to 2.65 meter per second. And now Q, as we all already know, Q, that is the discharge, that is a 6 meter cube per second, is already given over here. So we are getting Vm1. By the similar way, we will calculate the velocity of outlet with the same formula what we used for the calculation of the velocity of the flow in the inlet. That is Q, will put the value 6, is already given in the question, 6 meter cube per second is equal to pi, that is 3.14, into D2, that is the second diameter, that is the diameter of external area, that is 3, into 0.3, that is the inlet and outlet wheel and inlet and outlet white, that is 0.3 into 3 into Vm2. So if we just calculate, we'll get Vm2 is equal to 2.212 meter per second. So now we have to calculate the peripheral velocity at inlet. So peripheral velocity, we know U is equal to pi dn by 60 is an universal formula. We will put the value pi as 3.14 into diameter is d1 is equal to 2.4 over here, 2.4 into n is 200 rpm, and we'll divide by 60, we will get 25.13 meter per second. So Vm1 is equal to velocity of reel at inlet. So since the discharge is radial, velocity of the reel and the outlet is 0. So we will just put this value Vm1 U by G is 9.81, that is equal to H is the head, minus Vm square by 2G. So we will just put these values over here, Vm into 25.13 divided by 9.81, that is 40, that is the head is already given here, head of the turbine 40 meter. So 40 minus that is 2.12 whole square, where we calculated over here, Vm square divided by 2 into 9.81. So if we just calculate, we'll get Vm1 is equal to 15.53 meter per second. That is the what we have velocity of the wheel at the inlet. So it, I think, is very much easy how we have calculated the velocity flow into the inlet, as well as velocity of the flow at the outlet, as well as the wheel in the inlet and the outlet. So we have understood how the turbine works. Turbine is nothing, just a rotating machines where the steam is being fed or the water is being fed on the blades of the turbine to move the turbine, move to it. We rotates to couple with the electrical generator to generate electricity for the transmission and distribution purpose. So I hope is clear pictures we have got what is the turbine and what are the numericals which can come in the examination point of view, even in a mechanical engineering, electrical engineering, energy engineering, energy management, as well as in even I don't know if it comes in the civil engineering part or not, but still I feel that it is a very much important topics, most probably in the mechanical part. So thank you very much, and we'll continue our next videos with the next new formulas, new topics, new numericals in our next class. Thank you and have a great day.